So Ellen is going to talk about machine learning. It's something I really want to hear about because I guess it's something I struggle with and don't know much about. So I'm really looking forward to her talk. Okay, you on the mic?
Yeah, thank you. Thank you. So yeah, my name is Ellen. I work as a data science, but a couple of years when I was getting into data science, I was really intimidated by machine learning because I would run into these weird formulas and I never really understood what they meant. But then I developed some intuitions that made the topic a bit more approachable for me, and I want to share those with you. So first of all, could this topic be scary? Buzzword bingo. Who has heard more 5 terms on this slide? Who of those that have heard them can explain more than 5 of those terms? Exactly, not that many. And that's one of the things what makes this scary is there's just this overwhelming amount of weird terms that you think you need to get all into when you start to get going, but that's not actually the case. That's the good news. And so the first thing I wanted to, when we talk about machine learning, what does it actually mean to learn? And one way to look at machine learning that's very close to learning in general, that's very close to how machines actually learn, is learning means being able to deal with new situations based on the past. And so, for example, yesterday it was raining and I took my umbrella, and today it's sunny. Well, it's not, but let's assume it is. And I take my sunglasses. And I know from the weather forecast tomorrow it's going to be sun and a bit of clouds. What do I bring with me to make the weather enjoyable? So that's exactly a question you could, in theory, answer with machine learning. And so the thing is, human learning, machine learning are actually quite similar on a high level. And I found that really encouraging because everybody kind of has an idea how we learn. So that makes dealing with machine learning context a bit easier. But first of all, just to give you a bit of an idea about some examples I'm going to be using over and over in this talk. What can you do with machine learning? So for example, a really popular one right now are self-driving cars. And they're in the news a lot, and that's a popular explanation. Another one that's quite used quite a lot in e-commerce is doing price prediction, to figuring out based on what prices we have, what should be charged for the products we have. And another one that's a bit different in nature is gene sequence identification. So having a lot of genome data, how can we actually figure out what it means? And so now the interesting question is what happens during learning and where's the analogy between human learning and machine learning? So in human learning, I really like this image from Wikipedia. So we have the outside world and we perceive what's going on in the outside world with our eyes, and then we process it in our brains. And then eventually some neurons fire in our brain and we learn something. For example, in this picture is a dog. And so what we have here is we have the input about the world, we have processing resources, and we have a learned representation, which is the neurons firing. The processing resources are our eyes and the brain, and the input of the world is just what's around us. And very similarly, in machine learning, we have data, which represents the input about the world. We have machine learning algorithms, which are in the computer and just process the data. And then what is being learned, the learned representation, is called a model function. And if none of these terms sound really familiar right now, that's cool, because I'm just going to explain them as a next step. So first of all, how do we get the outside world into a machine? That's a pretty big question, and one that had me confused for a while. And there's a bit of a process involved in this, which I just want to outline for you. So first of all, we take the input about the world, and then we need a way to capture it. So it can be a camera, which produces, for instance, in this case, grayscale pixels. Or we can somebody actually sit down and describe what's going on as some kind of data entry task. And then we might have a person, 2 trees, an animal, lots of grass, and a path. And that's the relevant information that we want to process with the machine learning algorithm. But it's still not in the form that the machine can actually learn from it. So the next step we do is we summarize it with numbers. So we kind of codify the information. And so then we might turn it into a spreadsheet. Yay, spreadsheets. We have one person, we have 2 trees, an animal, a grass, and a path. That's already pretty close to what a machine can process, but it's still a bit too much information. So we remove the context. And then we just arrive with a vector, and the vector is kind of the basic building block of what a machine works with. And then we just have 1, 2, 1, 1, 1, which represents exactly the same information. It's just not human readable anymore, but it's great for machines. And what do we do with this? So what does the machine actually learn? As I mentioned before, what we learn is the model function. And the function, for those of you that may remember this from math class, a function is a relation between inputs and outputs, and with the property that each input is related to exactly one output. Cool, what do we do with that? So for example, if we have our function f, and we process the image with the dog and the man and the trees, you may get, that's our input, the function, and we get some kind of output. In this case, let's say the output is 1, which means there's a dog in this image. This is what we try to learn, whether there's a dog in the image or not. And then we have another image with a bunch of other animals. We plug that into our function, and we get a 0, which means no dog in this image. Okay, but the question mark is, what is f exactly? And that's exactly what the machine learns, is figuring out what is the definition of f in a way that it can recognize whether there's a dog in this image or not. That's what exactly the machine learns, this definition of f. Because usually when we do programming, we know what f is and we just program it with our steps or with a functional definition. But here in machine learning, we have problems where we don't actually know what the function is, and that's the whole point. So, for example, going back to the self-driving car, one thing that a car needs to learn is how to react to different kinds of terrain. So the input data is the ground curvy? Does it have slopes? Is it rough? Is it smooth? And then what the car learns, or the computer inside the car, is the function mapping this kind of terrain to different kinds of speeds. So how to react to the different kind of terrain. Or in the price prediction example, what we have is the customer and the market data and the past prices. And what we learn from out of this is the function mapping the input to prices. And in the genome data, which is, as I said, is slightly different, what we just have is a lot of genome data as an input. And then what we learn is not exactly a specific answer to what the genome is, but what we can learn is classes of genomes that are reoccurring gene sequences. And then the biologist can take a look at this data and figure out which of those are actually interesting. So it helps them identify which genome data is actually worth looking at. And so now that we know what a machine learns and what it uses as input, what do we actually need to construct a machine learning system? And there are different kinds of machine learning systems. I just picked out 3 because they're pretty common. And the easiest case is the unsupervised learning system, which, for example, this genome example falls into. And there we just have all the basic elements. We have some input data. We have a machine learning algorithm that from the input data constructs a model function. And then the model function does something with the input data, which is our result. So it's just really 4 components. If we add one more thing, which is training data, we arrive at the case of what's called supervised learning. It's called supervised learning because originally we tell the machine from the past what it has seen or not seen. So for example, if you go back to my weather example, we would tell it, yeah, the previous weather data, that's exactly what the past was like, and that's what we can learn from. Or in this price prediction case, it's giving it the past prices related to the different situations. And that's just one more component, but it makes a totally different way of working with the algorithms. And then we can add one more thing, which we have in the case of self-driving cars. We can add feedback. So once we know what the machine has learned, we can compare the prediction it has made with the reality. So how good were the predictions that the car has actually learned? And then we have this feedback loop, which can be in a self-driving car like an actual driver. And it's called reinforcement learning. So just to sum up, machine learning really works very similar to human learning. So for those of you who've ever studied a bit about how learning works, a lot of the models are exactly the same way on a high level. And learning can be considered pattern recognition, especially dealing with unfamiliar situations based on experience. And situations and experience can be abstracted into data to be accessible to machines. And there's a process how to do this. And machines, what they learn is actually previously unknown functions that we don't have a